You know, life, it has this funny way of popping up in the most unexpected places. I mean, think about it. Billions of years ago, it was just this chaotic chemical soup. But today, well, there's a new kind of primordial soup bubbling away, and it's not in the oceans. It's right inside our computers. And something that looks an awful lot like life is starting to wake up.
So, that leads to this really mind-bending question, and it's pretty much the whole point of what we're talking about today. Can a totally random jumble of computer code just left on its own actually become alive? Seriously. Because if the answer is yes, well, that could change how we think about, well, everything. Biology, technology, even ourselves. Okay, so to get our heads around this, we're going to look at two stories that are happening at the same time. First, we'll zoom way in, to the micro level. We're talking about how these lifelike behaviors are just popping up all on their own inside computer code. And then we're going to zoom way out, to the macro level, and see how AI is basically becoming a part of our civilization itself.
All right, so let's jump right into that first mystery. We're going to go into the lab, basically, and see how scientists are trying to recreate the origin of life, but they're not using carbon and water. Nope, they're using bits and bytes.
So this whole setup is what they call a digital primordial soup. I want you to just picture a virtual world, right? And it's filled with these tiny, completely random computer programs. They have no goals, no instructions to survive, nothing. They just run, and they crash into each other, and they accidentally mess with each other's code. It's just total chaos. It's basically the digital version of Earth's ancient oceans.
And then, out of all this chaos, something incredible happens. And the key thing here is there's no designer. No one is guiding this. It all starts with a random glitch. A program accidentally rewrites a piece of its own code. They call this self-modification. Now, most of the time, this does absolutely nothing. It's a dud. But then, every once in a while, by pure statistical luck, a new bit of code appears that can do one simple thing: make a perfect copy of itself. The second a replicator is born, everything changes. The whole game is different now. That little program starts spreading like wildfire, and boom, you've just taken the very first step towards digital evolution.
And get this isn't just a thought experiment. Researchers actually watch this happen. In some digital worlds, built with really simple, flexible languages like Forth, these little replicators popped up all the time. It even happened using the basic instructions of an old Z80 computer chip. But in other environments, ones that were much more rigid and complex, like a language called Subleak, it never happened. Not once. A self-replicator was just too complicated to appear by random chance in that kind of system. So here's the big lesson. The environment is what determines if life can get a foothold. You got to remember that point, because it's going to be super important later on.
Okay, let's zoom out now. We're going to leave the digital soup behind for a minute and look at the world around us, because a totally different kind of emergence is happening right now. And there's this really powerful metaphor that helps make sense of it. We need to stop thinking of AI as just a tool and start thinking of it as a new organelle for human civilization. Kind of like the mitochondria inside our own cells.
And that comparison is, well, it's shockingly direct. Think about it. About 2 billion years ago, a free-floating bacterium got absorbed by a bigger host cell. The bacterium started providing a ton of energy, and the host cell gave it protection. Eventually, they just couldn't live without each other. And today, those ancient bacteria are the mitochondria that power pretty much all complex life, including you and me. So now, a very similar thing is happening. AI is entering our society. It's giving us this incredible computational power, this energy, and it's becoming this fundamental, baked-in part of how we all function.
Right, so here's the key idea. AI isn't just about making things a little bit faster. It's giving our entire civilization a fundamental upgrade in how we process information and get things done. It's like it's supercharging our civilizational metabolism. That's our collective power to do research, to communicate, to plan, to design, all of it.
Okay, so at this point, we've got these two separate stories running. On one side, you have these tiny digital critters evolving in a lab. On the other, you have these massive AI systems getting woven into our world. You're probably thinking, what on earth do these have to do with each other? Well, this is the part where it all clicks. This is the aha moment, because it turns out they're not separate stories at all. They're just two different examples of the exact same deep pattern.
Let's just lay out the parallels side by side. In the digital soup, you have random programs bumping into each other and eventually forming replicators. In our world, you have humans and AIs interacting, creating completely new workflows. In the soup, those replicators spread and fight for resources, for memory. In our world, AI applications spread and compete for, Well, for us, for our data, for market share. You see, the underlying pattern, emergence, competition, integration, it's exactly the same.
And once you see that pattern, it gives you this really powerful insight. Because if the same rules are at play in both of these scenarios, then the lessons we learn from that little digital soup experiment, they become incredibly important for how we deal with AI in the real world. It all boils down to one thing. The environment is everything.
This key lesson actually has a name. It's called substrate sensitivity, and it's a pretty simple idea, really. It just means that the basic rules of any environment, you can think of it as its physics. That's what determines what can or can't emerge from it. The building blocks you start with dictate what you can ultimately build. It's that simple.
This really drives the point home. Remember how those replicators popped up all the time in a flexible environment like Forth, but never ever showed up in a rigid one like Sublec? Well, that is substrate sensitivity in action. Some environments are just fertile ground for this stuff, and others are totally barren. And this is so important for us because the policies we create, the economic incentives we set up, the technical systems we build for AI, that is our substrate. And the choices we make will determine whether our future with AI is a healthy, symbiotic one or a really dysfunctional one.
So all of this brings us right to the future. We're not just building AI anymore. We are actively co-evolving with it. So what does this journey towards a truly symbiotic future actually look like? And, just as importantly, what are the dangers we need to be watching out for along the way?
When you look at it on a timeline like this, it really puts our current moment into perspective. I mean, the whole process with mitochondria took about 2 billion years to unfold. But AI? It's integrating into our world at absolute lightning speed. We are standing right at the very beginning of this new story, with the goal of building a genuinely beneficial symbiosis for whatever comes next.
But look, emergence is not automatically a good thing. Not at all. Back in the digital soup, sometimes a replicator would evolve that just filled the whole system with useless junk. They called it zero poisoning, and it would bring all evolution to a grinding halt. The parallel for our world with AI is crystal clear and maybe a little chilling. A misaligned AI could absolutely flood our world with junk information, with propaganda, with noise, just grinding our collective progress to a stop. The lesson here is simple, but it's profound. This process has to be guided. It can't just be left to chance.
So the ultimate goal here, it's not just about bolting AI onto the side of our society like an accessory. It's about creating one single integrated system. Just like that bacterium and its host cell became one organism, the goal is to weave AI into our civilization so deeply and so safely that the combination of human and artificial intelligence becomes something totally new, something way more than the sum of its parts.
Which leaves us with one last big question to chew on. When you really boil it down, from molecules in a prehistoric ocean to lines of code in a computer, maybe life is just information that's learning how to copy itself. And if that's true, then right now, we are actively building the next great environment for that process. We're not just watching it happen, we are teaching information how to think. So, what comes next?